Okay.
Okay. So thank you to everybody. And this is the section number 16 of the international conference on energy security. And my name is Arturo Lorenzoni. I'm professor of energy economics at the University of Padua, and I am chairing this session, which is focused on energy and the economy, examples of interconnection. So we are hosting 3 presentations. Unfortunately, one of them cannot be given this morning because of some health problems of the author, Mr. Gronwald. So we will not hear the presentation about measuring multi-scale connectedness between green bonds and equities using a thick pen method. So you will find this material in the proceedings of the conference, but unfortunately, this morning, Mr. Gronwald cannot be present. We will go ahead with the first presentation, which is given by Dr. Antonio Caputo from ISPRA, which is the most valuable institution in Italy about environmental protection and connected to the Italian Ministry for the Environment. His presentation is related to the PULVIRUS project, a pilot study to evaluate the impact of COVID-19 on the Italian economy and the energy system. So exactly what this session wants to address, the connection between the economy, and we had really an unusual situation for the economy in Italy, as in most of the world in 2020 because of the pandemic, and the energy system. So I would leave the floor to Dr. Caputo, which I see connected here. And please, the floor is yours. You have time to present your work. And if you want to share your slides, I think you can do that.
Okay, thank you to you. I'm sharing the slides. Just a second.
Okay, perfect. We can see it.
Okay, it's on full screen.
Yes, it's perfect. We can see perfectly.
Okay.
Thank you.
Thank you to you. Good morning, everyone. I'm Antonio Caputo, and together with my colleagues Camporeale and Peschi, although I'm the only speaker, I'll present the results of a pilot study to evaluate the impact of COVID-19 on the Italian economy and energy system. The study is framed in a bigger project, PULVIRUS project, which involved the cooperation between 3 research institutes, ENEA involved in technology and energy side, as the environmental side, ISPRA, my institute, and ASS for the health issues. The project was mainly oriented to investigate the relationships between the COVID-19, best to say the lockdown measures put in act to stop the COVID, and the effects on the energy system and so on, with an eye on the relationships between the environmental conditions, mainly particulate matter or other pollutants in the atmosphere, and the diffusion of COVID-19 and the hardness of the disease. The project was sliced in many activities as ours. We are focused on greenhouse gases emissions reduction due to the measures as lockdown, which was implemented to break the diffusion of the pandemic. I will remind that the total lockdown was from 9th of March up to 19th of May, while in the rest of the year the lockdown was only partial, but anyway enact. So we gathered all data to evaluate the impacts of COVID-19 on energy consumption and economy, with the aim to elaborate a tool, an analytical tool to make earlier estimates of greenhouse gases emissions, having in mind the ambitious task to answer such questions. Now, give a look to such graph. As we know, the pandemic triggered a hard GDP fall worldwide. In Italy, the situation was even more serious because when the pandemic broke out, the country was still recovering. The crisis started in 2008 with a GDP fall of about 5%, followed by other fall down. We really recovered the lost GDP only from 2015, suddenly interrupted with the worst fall in the last 25 years of the GDP. GDP is the blue line, and obviously the figures are on the right axis, while on the left side we see the index number with the year variation of the services, agriculture, the yellow, the orange, and the industry that was the most affected sector from the crisis in 2008 and also in 2020, as you can see here. The last provisional number say us that we are recovering completely at pre-COVID level in 2022. We will see what the future reserve has with the energy crisis ongoing. On the energy side, here we see the yearly change of final energy consumption by sector as compared to 100 in 2000. So we are seeing the relative change of any sector. Services increased their final consumption in the long-term trend, but had suddenly decreased the worst in their history as the transport sector, respectively 19% the transport and 9% the services. As for industry, the situation is more complicated. It was not in 2020 the worst fall, that was about 4%, but in the 2008 crisis with about 17% below the previous year. The trend in the industry sector is quite complicated because it is not only affected by contingent situation as crisis by economical side or outside, but it is also hardly affected by an increasing pattern of efficiency use of the energy. As for the households, we cannot attribute the reduction to the COVID because it is widely oscillating depending on climatic condition, which determines the heating or cooling demands. Here we come to the most interesting graphs because are at monthly level, so they allow us to follow as near as possible the ongoing events, and also because it concerns one of the most important resource in the Italian energy system. Natural gas satisfy about 40% of our energy demand, the gross energy inland consumption. As you see, the total consumption is made of the sectors of distribution, which supply natural gas to services and households, power plants, which produce thermoelectricity, and industry that use natural gas for their processes, and also for the production of electricity consumed inside in the plants. The shape of the consumption is concave due to the highest demand of energy in the cold months. But what is important to see is the really different trend of the black line, which concern 2020, compared with the other years, the past years and the future years with the 2022 ongoing. Here we see the highest reduction of energy request in the month of April and May, with a recovery only from June, July, and in the second half of the year, we see that the black line is quite overlapped with the other years. The same trend we can see at the distribution level, with reduction even more depth. As for power plant, we cannot see a peculiarity in 2020 because the black line is quite intertwined with the brown line that is 2018. The peculiarity we can see at the industry, where there is a really funnel shape with 1/3 of loss of energy by natural gas, and a recovery only in July. So this graph shows us also a sort of stress test of our system, industrial system. The problem with this sector really continues also in the ongoing years, the red dotted line, but we know it is for other reasons. The electricity demand, maybe better than other graphs, show us the peculiarity of 2020, because the black line rapidly depart from the wave of the average years of the other years. We have a loss up to 19% of electricity demand, mainly driven by the industry demand of energy or electricity. Here we come to transport fuel sales. It is a really important sector because it was the most affected sector during the lockdown period. I remember that the lockdown blocked completely any passenger movements from March to May, while guaranteed the freight transport. So this difference is evident also in the difference of reduction of fuel required, because gasoline fueled only car in substance, while diesel is used also in the freight transport. So we see 74% of reduction in the gasoline line and 60% in the diesel line. You can see that also the rest of the year remained below the other years. The request of fuel was depressed along the 2020, and we will see that such depression is reflected also in the emissions of greenhouse gases by this sector. Here come to the heart of the presentation and our analysis, because all that seen until now, as concerns the energy side, must be translated in greenhouse gases emissions estimates. So, as the other slides, the black line concerns 2020, and as you can see, as for solid fuels, we cannot see a particularity. The solid fuels reduced their emissions with a long-term downward trend, but in the last year they are recovering. But anyway, we cannot attribute to COVID a particular behavior to this fuel. Something peculiar is evident by the liquid fuel side, because they are mainly used to fuel the transport. And we have in April 2020 about half reduction of the request, and the remaining depressed the emissions, sorry, also in the rest of the year, notwithstanding the recovery, the climbing of the funnel. Here we have the natural gas. The shape of the curves are quite the same, not in the first half of the year. They are quite heterogeneous, with 2020 lower than any other year. Here we see the all-time series of greenhouse gases emissions since 90s. The percentages on the bars are the average rate year by year. Here we have a 5-year interval. As you see, the top of our emissions was reached in 2005 and then decreased not constantly, because in this period a great push was given by the economic crisis, but it was not only a contingent problem that determined the decrease, which continued along all the years, but there was also a constant fuel shift towards natural gas, the development of renewable sources, the efficiency use of energy, and so on. But in 2020, this line was rapidly interrupted by COVID, so the emissions reduced by 9%, about 9%, not the highest one-year reduction that was recorded in 2009, following the economic crisis, about 10%. Provisional data for 2021 and 2022 say us that we are fully recovering our emissions, almost at the pre-COVID level, as you can see by the comparison of these two bars. Here we see the comparison between 1 year and the previous one, sector by sector. Please pay attention to the orange line, that is the 2020 versus 2019 comparison. You can see that most of sectors was affected by the reduction. Here on the civil side, we cannot say that is due to COVID, because it is not significantly different by others years, while the difference is recorded in a quite evident way in the transport sector, which is the most affected sector. As for agriculture and waste, the processes emissions by these sectors, we see that the 2020 increased their emissions. The last box refer to the total emissions, and the last 2 years say us that we are recovering as previously seen. Now, just to conclude, what have we learned by this experience? Our task, I reminded, it was to develop an analytical tool to perform earlier estimates of greenhouse gases emissions. Our objective was to be a delay of only a few months. We have emissions estimates at October 2022. Only 2 months ago. This is a way to follow as near as possible the ongoing impact of the lockdown measures, but any other measures we can adopt to reduce greenhouse gases emissions. It is quite evident that the last 2 years say us we need both measures to reduce greenhouse gases emissions and the tools to evaluate the effectiveness of that politics and the measures. By my side, I think I have said anything I have to say. Thank you for your attention.
Thank you very much, Antonio, for the presentation. Very interesting. Lot of data about the evolution of the energy demand in Italy and the related emissions. I think we can pick some demands, some questions from the floor. So if any of the participants wants to put a question to Dr. Caputo, I think we can do it now. And I start with a question myself. You presented the gas consumption comparing different years in one of your slides. And of course, there is the strong reduction in the first months of 2020. But I was really surprised also from the trend in the consumption in 2022, which is quite different from the other years.
Yeah.
Can you explain that?
Yes, we know that 2022 is the ongoing year with a great problem on the energy side as for the supply of energy. Best of all, the different use in different sectors of energy. Because on the side of total supply of natural gas, I do not see difference between 2022 and 2021. But it's different, the location of natural gas on the industry side. All the natural gas we are using now is on the side of power plants and civil sector. The industry is suffering a new crisis, I'm afraid.
Okay, thank you very much, because yeah, it is surprising that there is a decoupling between the gas consumption and the GDP, which is somehow unexpected, because we were studying a correlation between GDP and the energy consumption overall. So maybe it is possible to decouple the energy demand from the economic growth.
Yes, we are seeing a significant decoupling effect between the two parameters, energy and economy side. But it is a real scene that it was industry the most affected sector, because the decoupling effect with the increasing energy efficiency is most on the industry side. We have a really decoupling, the right decoupling, only on the industry. not on the services that where we observe a decoupling, but in the opposite side. Energy is increasing and their value added is also increased, but below that level. But I remember another important issue. We have seen the relative change of the energy demand by the sectors. As for the absolute demand, energy required by services is around 17%, while industry is a more energy intensity sector with about 24%. The real troubles are on the civil sector, which required about 50% of our energy demand. It's they are the sectors on which focus our attention in the future if we really want to perform to achieve our tasks concerning the reduction of greenhouse gases emissions.
Thank you very much. And I also have another curiosity related to 2020. Mm-hmm. You have shown the trend about the emissions, the CO2 emissions, divided by sector. And agriculture and waste have increased the emissions during the year. I could expect for waste because people were staying at home and probably produced more waste.
Yes, but they are peculiar sectors and also peculiar emissions, because we are referring to the processes side of the emissions, not combustion emissions, not energy emissions. And the emissions by, first of all, we have to say that agriculture was not limited by lockdown, was not touched by measures to stop their activity, their economic activity. But that emissions, the processes emissions, depends by biological effects. Cows continues to eat and to live and so on. So it is really independent by the years. If we going to see other years, we could observe the same increase as well, same decrease. It does not depend from any measures on COVID-19 side observed.
Okay. Thank you. Thank you very much. So it's very interesting to make such kind of analysis because you have an idea of what is the effect of the different choices. So thank you very much, because I think this work is very useful.
Thank you. Thank
you. I think we can move now. I mean, I don't see any question in the chat, so probably I don't know if the attendees want to put other questions to Antonio Caputo. If you have more questions, please use the chat and write on the chat. We can try to move to the second presentation, which is from Geoffrey Mutumba, and is related to the electricity consumption, foreign direct investments, carbon dioxide emissions, and economic growth in Uganda. I see Mr. Mutumba connected, so I would leave the floor to you, Geoffrey, if you are there. Okay, welcome. I don't see you anymore. Okay, here we are. Please, Geoffrey, the floor is yours. We can hear you. Try to speak. Geoffrey, we hear you. Please speak. Okay. Please try to speak, Geoffrey. No, now the microphone. Okay, try now. We hear noise from your keyboard, so please.
Well,
okay,
yes,
perfect. We hear you.
Good morning to you.
Good morning.
Good morning.
Please, the floor is yours.
Thank you very much. Sorry I got that technical problem, and just on the new, then I had to use another gadget. Right now I'm trying to set my slides on the new gadget, and that should just be within a minute, and then I will get started. Yeah, trying now to share the screen. Still opening. Are you able to see my screen?
We see your screen. Yes, perfect.
All right. Thank you very much. This is Geoffrey Mutumba, and my topic is electricity consumption, foreign direct investment, carbon dioxide emissions, and economic growth in Uganda. And this is the layout of my work. Is the introduction, and I'll do the literature, the methods, findings and discussion, and conclusions and recommendations. Electricity is a key driver for industry operations, which in turn promotes economic growth. Quite a number of studies have looked at how electricity consumption promotes economic growth. The case of Uganda, the government of Uganda has been investing in electricity generation, distribution, and consumption. And this is mainly dominated by the foreign direct investments. Most of the money that is into the electricity sector is mainly by these multinational corporations and FDIs, with the hope that this will achieve the much needed economic growth. And that's why this study is focusing on how these variables, electricity consumption and FDI, feed into economic growth. So the multinational corporations that invest in the developing nations tend to use technologies that are not too strict on carbon dioxide emission standards. Quite often, these developing countries have not set a good legislative framework to monitor and ensure that these multinational corporations stick to the carbon emission standards, both at the international and the national set standards. And this only worsens the carbon dioxide problem, as is shown in the pollution haven hypothesis. This has been also alluded to by Balsalober and Sina in their studies, that some of these multinational corporations leave their home countries to come to the poor nations because these are not too strict on the emission standards. And while they're here, although they are able to produce goods and services, but this is at a greater environmental cost. Therefore, this study seeks to investigate the relationship between these variables of interest. It will investigate the causal relationship between electricity consumption and economic growth. It will investigate the causal relationship between FDI and economic growth. It will also investigate the causal relationship between carbon dioxide emissions and economic growth. And those are the accompanying research questions. The hypothesis, this study is into four main arguments that lend themselves to empirical testing. The very first is the growth hypothesis, whose argument is that there is a unidirectional relationship running from electricity consumption to economic growth. As set out by those scholars, their studies have revealed the same findings, that there is a relationship that is running, the direction of causality is from electricity consumption onto economic growth. Other studies, however, indicate a bidirectional relationship between electricity consumption and economic growth with feedback loops. You find that in the short run, the causality is running, say, from electricity consumption to economic growth. And in the long run, it is reversed from economic growth to electricity consumption. And those are the studies that Zafar, Salahuddin, and Gao, Wang, and et al. There is also a hypothesis, an argument that the direction of causality is from economic growth to electricity consumption. And those studies have shown that, while other studies indicate no causality between electricity consumption and economic growth. Given the central debate here, it therefore shows that there is a lot of controversy between the scholars, and there is no agreement on the direction of causality between electricity consumption and economic growth. This study, therefore, is also to investigate this matter further with a view that will be able to discern the direction of causality of electricity consumption and economic growth for the case of Uganda. Its contribution is that it will use a multivariate framework of analysis with a standard economic growth model, which will help analyze the relationship between electricity consumption and economic growth using the neoclassical production function, particularly the one of the solo growth model, which will use now FDI and carbon dioxide emissions as controls of the model in order to reduce the omitted variables problem. Those studies that have used the bivariate analysis often end up in a problem of omitted variables problem, as shown by Lutkeppel in his paper 1982 and even in his paper of 1999. Therefore, this is a superior technique by using several variables in a multivariate framework of analysis. The study will further investigate the direction of causality using the vector error correction mechanism and the Granger causality test. When we interrogated the data, we realized that a long-run relationship exists. And because of that, it is the co-integrating equation that has been able to lead to the use of this vector error correction model. It will also examine the significance of the energy policy framework in promoting all-inclusive growth. Quite often, conventional economists are interested in looking at economic growth per se. It's about how much can we increase the matrix of goods and services. However, it's also important to see, does this growth benefit all the individuals? Is it going to help trickle down to every citizen within the country? So using electricity because electricity and other energy goods are reaching out to all, are used widely by all the citizens. It's also important that the growth dividends are also shared across most of the society members. The empirical literature, electricity consumption, foreign direct investment, and economic growth. The organization of the literature was to try and see what the scholars have been doing in the field. That while many scholars argue that foreign direct investment leads to cleaner growth, as shown in the paper by Copeland and Taylor, the other scholars that argue that foreign direct investments in less strict and more permissive regulatory environments have led to dirtier production and growth. And therefore, this would need to be checked, because the current debate is that we would find cleaner mechanisms of promoting growth. But for Uganda, there is no information to that effect and must be investigated even further. When the multinational corporations are located in countries with strict environmental laws, it is where those foreign direct investments enhance their movements to economies with more environmentally relaxed regulations. So, as elsewhere, where these FDIs are hosted, regulations are becoming more stringent. Now it happens that they will move away with an intention to go to the developing world where the restrictions are not as serious. And by doing that, then they will lead to, they will be now leading to growth, but with dirtier production means, which is not helping the global community, but it is also not helping the local communities where this production is going on. Yeah, some studies indicate that increased carbon emissions lead to economic growth. This is still controversial, but there are studies that have indicated that as production is going on, we have the electricity consumption and production is going on, but carbon emissions are also increasing, and that has, in some instances, led to economic growth. On the contrary, however, there are others that show that increasing carbon emissions would erode away any growth benefits, as shown by papers by Grossman and Kroger, Valsapol, Mazur, and Giovanni, that argue that carbon dioxide emissions do not lead to increased GDP. Okay, that the methods, the data used was mainly secondary time series data from the World Bank statistics, and the variables included electricity consumption, foreign direct investment, and the carbon dioxide. The leading theoretical framework was the neoclassical growth model, particularly the one of Solow growth model, because Solow devised an appropriate production function in which he looked at output as a result of factor inputs, labor and capital. However, in energy economics, we have argued side by side that in fact energy is an important input as well. And within that model framework, we've been able to add the controls of the model, foreign direct investment, and carbon dioxide. The econometric model has used the vector error correction model as earlier stated, and this has been prompted mainly because of the long-run relationship that existed and the co-integrating equation. And the variables being endogenous, energy, carbon dioxide, and FDI being endogenous, and looked at and seeing how these would be affected when economic growth is varied, and the structure setup of the model has been given there. We can see the co-integrating structure and the error correction technique that is showed by that summation there, that we are looking at how to analyze the relationship and the error correction model being compared with the lagged values of the error term from that co-integrating equation 5. The findings, we were able to do some diagnostic tests, and the stationarity was tested using the augmented Dicker-Fuller test that indicated that electricity consumption is non-stationary at levels while it becomes stationary at first difference. And the co-integration relationship, this was testing for the long-run relationship. We used the Johansen trace and the Marc's test statistics, and these suggest the existence of at least one co-integrating relationship between GDP and electricity consumption. Then the Granger causality was the test used. The standard Granger causality test indicates that a causal relationship running from electricity consumption to economic growth. Therefore, a long-run causality that runs from electricity consumption to GDP is confirmed, and this gives us the growth hypothesis. The foreign direct investment also Granger causes GDP in the long run, and carbon dioxide also Granger causes economic growth. That means that all the variables of interest here have a positive relationship, and Granger cause economic growth. Okay, the vector error correction model shows a unidirectional causal relationship that is running from electricity consumption to economic growth. This supports the growth hypothesis, which implies that efforts must be geared towards increasing electricity consumption, as this brings with it positive multipliers to economic growth. There is also a positive causal relationship running from carbon dioxide to economic growth and FDI to economic growth. That therefore means that the hypothesis of the halo hypothesis has been confirmed, that these countries, these FDIs that come in to invest will have an influence on the relaxed atmosphere and emit as much carbon dioxide as possible. That's why you see with increasing carbon dioxide emissions, you have increasing GDP. A positive relationship running from electricity consumption to GDP supports the growth hypothesis. And the results that indicate a long-run relationship also confirm this. But this implies that increasing electricity consumption will promote economic growth. And therefore, it would be important now for the government of Uganda to continue investing into the electricity infrastructure, because it is a precursor to economic growth. And these results are in agreement with earlier studies. Zhang and 2020 found a similar relationship. Similarly, positive relationships between carbon dioxide to GDP exist both in the short and long run. This implies that an increase in the values of foreign direct investment as well as carbon dioxide emissions would foster economic growth. The results indicate that there is a long-run equilibrium relationship between real GDP and electricity consumption, carbon dioxide, and FDI. The coefficients for the real fixed gross capital and labor force are positively and significantly and statistically significant at the 5% level of significance. Therefore, it would mean that for our study, government of Uganda must continue to invest further into electricity consumption in order to bring about economic growth. I want to thank you very much for listening to me, and Chair, that ends my presentation on this. Thank you very much.
Thank you, Geoffrey. Quite interesting to see that there is a correlation between energy demand and CO2 emissions and the economic growth. May I ask you if you have any evidence? I mean, you are talking about the relationship, and you say about some data from Uganda. We didn't see any data. So do you have any value related to the study you have made about the Ugandan case?
Pardon? Pardon?
No. Okay.
Hello?
Yes, we hear you.
Yes, I didn't get the question properly. I had a case of information from Uganda. Yes, the information, the data I used was from the World Bank statistics, because that's where the long-term series could be properly got. The World Bank statistics is what I used to put together information on Uganda. And this is because there has been a gap. Earlier studies were mainly looking at electricity consumption and economic growth, but there was no deliberate effort to see the impact of investment, especially foreign direct investment, and also the effect of carbon dioxide emissions on economic growth. So this study further goes ahead to investigate that using that data, which was from the World Bank statistics. And it covered quite a number of series from 1982 to 2018.
Oh, okay, thank you. I don't know if there is any question for Mr. Mutumba. In case you can use the Q&A session in the Zoom screen, but I would give the floor to Antonio Caputo, because there were some questions related to the data he has shown from Xi'an. So if you want, I think that you have given the answers in the Q&A session, but if you want to add something, please, you can give the answer.
Okay, the question was if we have compared the 2009 and the 2020 events in terms of energy and GDP reduction. Not yet in an exhaustive way, entering in the issues in exhaustive way. But we have seen some really determining difference. Consider that the total GDP decreased much more in 2020 than in 2009. And consider also that industry did not show the hardest case in 2020, but in 2009. On the other side, services experienced their worst case for the pandemic, and represents about 3/4 of our GDP. On the other side, industry is decreasing the share of GDP. So the reason of the difference between the crisis, the economic crisis determined in 2009 and 2020, most hard in the last years, is due mainly to the prices in the services sector and the increasing role of this sector. But we need more detailed analysis to see really what are the differences. We have also another world with different amount of renewable sources, different scenery of efficiency. I have said that industry has performed an increasing, a really strong increasing pattern of efficiency. And we need to enter into the detail in a most extensive way.
Thank you very much.
Thank you.
So I don't know if there are other questions for the speakers. Okay. So maybe I have one curiosity for Mr. Mutumba related to the energy demand growth in Uganda. I mean, can you tell us something about the evolution of the energy demand in your country? What is the growth rate for the energy demand? And which are the energy sources which are used to supply energy in Uganda? And so that we can understand if there is the possibility to increase the energy supply to support economic growth.
Okay. Yeah, thank you very much. Energy demand in Uganda has been growing, and in the period between 2000 to 2018, it has grown by an average of 8%. So energy consumption is growing very fast compared to the global energy consumption, which has been growing by 1.4% in the same period. Now, that was the period 2000 to 2019. The time of 2020 has been left out in this study because of the issues of the COVID pandemic, which would distort all the data. But therefore, the growth of energy consumption in Uganda is growing at such a high rate of 8%. Now, the energy sources, Uganda's energy mix is such that renewable energy has the largest contribution because renewable energy is 92% against the 8% from fossil fuels. So the main energy source here is biomass. Biomass has the largest contribution, which the traditional biomass, 89%, while electricity is 2%. Now, this 2% electricity is what was of interest to me, and Uganda's energy generation is 1,350 megawatts. 80% of this is from hydroelectricity. That's over 1,070 megawatts from hydroelectricity, which is 80%. And that is followed by bio cogeneration. By getting electricity from bagasse, we are also able to generate another 111 megawatts, which is 8%. Now, solar photovoltaic contributes 64.5 megawatts, that is about 4%. Now, we have the thermal cogeneration from diesel engine, from diesel, we also generate another 101 megawatts, which is 8%. So in the electricity mix, you will realize that also it is mainly renewable electricity. 92% is renewable electricity. And currently, why also studies of growing interest to Uganda is that Uganda now generates more electricity than it consumes. You realize that the generation is 1,350 megawatts against the peak demand of 900 megawatts. So now that leaves us also in a lacuna because you're producing 1,350 and only consuming 900, leaving a reserve capacity of 33%. Now that means that has an effect on economic growth, or will still have an effect. Although we are trying to export some to Kenya, the neighboring countries. However, the grid infrastructure is so old and in need of repair, so cannot dispatch that electricity as required. Yeah, so that is to throw some light on Uganda's energy mix. The sources are mainly biomass, electricity, and also the fossil fuels, which make up just 9%. Thank you very much.
Thank you very much. And can you remember me how many inhabitants are living in Uganda?
Well, Uganda's population is about 45 million Ugandans. The last census was carried out in 2015, 2014, and there were 34.9 million. But with Uganda having one of the highest growth rates at 3.1%, the population has now grown up to 45 million Ugandans. Yeah.
Thank you very much.
You're welcome.
Thank you. And yes, I see a question for you, Geoffrey. Is biomass energy commercialized in your country? This is from Zangui San.
Yes, good question. Uganda's biomass is not commercialized. It is still the traditional biomass where the markets are not well structured. And this creates a lot of challenges for regulation. One, people fetch firewood and go into the nature, into the forests and cut the trees. However, now rudimentary markets are coming up. When they burn the firewood into charcoal, they will now take the charcoal to the market. That is an informal market. There's no regulation there, but it is sold. So we cannot say that the biomass has a market. It is still that traditional biomass where it is a matter of picking trees from the forest and firewood and meeting the most immediate need. In fact, this is used a lot into the cooking. Most of the cooking is done using the traditional biomass. So that is now an area where there is a gap that we now need to go into modern biomass, modern bioelectricity. So if we can also develop, and really we need information to inform policymakers and government that the firewood that is being cut is at a high environmental cost. But otherwise, there are no markets. Thank you.
Thank you very much for your answer.
You're welcome.
I see another question for you, Geoffrey.
Okay. Yes.
In your opinion, during the period of study, foreign direct investments contribute successfully to decoupling the economic growth from the environmental degradation, CO2 emissions. So what do you think about the relationship between foreign direct investments and environmental performance in your country?
Well, thank you very much. According to this study and the data that has been used, it is showing that foreign direct investments are contributing to economic growth. And what does that imply to the environment? We have also seen that carbon dioxide emissions also increase directly with economic growth. But this is in agreement with the environmental Kuznets curve, that some of these countries at a lower level of development may at the start, as they are polluting, they are growing. However, this will reach a point, the inverted U, when all these growth benefits will be lost. So that is why, to me, I think even though the results are showing a positive relationship between carbon dioxide and economic growth, we should not take it for granted. Measures should be put in place to try and overcome that. We should try and control the carbon dioxide emissions. We should put clear regulation. So we shouldn't look at the field data here and it tells us that information, because we now know the current level of debate that already the carbon dioxide emission is at such a high rate that, given the data for Uganda, the picture is not so alarming, but it should be put under control so that we try to have cleaner production mechanisms. Yeah, thank you very much, Chair.
Thank you. Thank you so much.
You're welcome.
Okay, I do not see any more questions from the floor. So I think we are approaching the end of this session. I ask for some support from the organization if we can close the floor. From Rome, do you have any suggestion? No? Okay, so I think we can close here. I thank you, the speakers, Antonio Caputo from ISPRA in Rome, and Geoffrey Mutumba from Uganda. Thank you for attending this session. I hope the information presented is useful for the research activity of all of you. And thanks a lot. I think we can close the session.
Thanks a lot to you.
Thank you very much.